Hello everyone, welcome to my demo video on the policies as a code on Azure for compliance with FedRAMP and NIST SP 853 standards. My name is Zoran and I'm thrilled to share this video today. We walk through the real-world scenario with a fictional government agency called FDOA to show how to automate governments for a production environment. The goal is to implement policy as a code using the Bicep for definition, VS Code for editing, Azure DevOps for repo and pipelines, and Microsoft Purview for AI-supported compliance monitoring. I'm using a modular approach with Bicep because it simplifies complex configurations, enables code reuse across the different resource groups, improves readability by breaking down large deployments into smaller, manageable modules, and makes maintenance much easier in the long run. This solution is ideal for smaller environments with just a few subscriptions, providing an efficient, straightforward way to manage policies. For more complex setups with 100 plus subscriptions, I recommend use Enterprise Policy as a code, which handles larger scales better, but that could be maybe topic of some future video. For regulatory compliance, I applied FedRAMP's moderate baseline initiatives, which provides a standardized set of controls tailored for the moderate impact systems, balancing strong security with operational flexibility, as it's suitable for the most federal applications without complicating things. We'll dive deep into the Bicep code implementation, explaining each part line by line to help you understand how to customize for your needs. Whether you're a beginner or experienced in Azure, this guide will empower you to enforce compliance efficiently and with confidence. Let's jump in and get started. Let's first take a look at the resource groups I've already created upfront for realism, simulating an existing environment, which really brings the scenario to life. And you'll see RG storage, RG networks, RG databases, RG identity, and RG test listed there. Inside resource groups, for RG databases, the SQL server, for RG networks, the virtual network, and for RG identity, the key vault. This shows how resource groups group resources by category for granular compliance. To confirm, we're starting fresh with policies. In the policy console in the portal, you'll see that no custom policies have been created yet. Let's open the already created Azure DevOps project on dev.azure.com. Navigate to the project FDOA policy project. In repos, you'll see the repository FDOA policy project is already set up. Now switch to VS Code. Open the folder at DOA Policy project. It's already cloned and connected to DevOps, with all files synchronized. This setup ensures all changes are tracked, reducing risks in collaborative environments. It's like having a safety net for your code. Exciting, right? Now let's open the already created policies folder in your repo, where I've prepared the key files. main.bicep for the global FedRAMP initiative with modular assignments, policy assignment erg.bicep as a reusable module for RG level policies, and parameters.json for dynamic values like subscription ID. We'll go through each file in detail, explaining the code line by line, including how it maps to NIST controls and common pitfalls like missing parameters. This is where the real power of IAC shines. Main.bicep, the entry point that orchestrates everything, including global FedRAMP and RG modules. Target scope set deployment to subscription level for broad coverage. Params pull from parameters.json. The FedRAMP initiative resource defines a policy set initiative with built-in definitions. Modules call policy assignment rg.bicep for each RG. Passing params to assign the initiative, this creates 7 policies. The output helps verify IDS post-deployment. Next, open policy assignment rg.bicep. a module for assigning policies to specific RGs, like RG storage or RG test. Param lines define inputs. Assignment name for unique ID, resource group name targets the RG, for example RG storage. Policy definition ID references a built-in or custom policy, for example for NIST encryption. And parameters for dynamic values like list of allowed locations to avoid errors. The resource block creates the assignment at RG scope, using properties to set details. This modular design allows reuse across RGs, enforcing granular compliance, like denying unencrypted storage SZ28. Common error. If policy requires parameters, for example, list of allowed locations, pass them via parameters object, or deployment fails with missing parameter message. Seeing this in action is so satisfying. It turns complex governance into manageable code. Before moving to pipelines, let's validate locally to ensure everything is correct. This step is crucial for catching issues early and building confidence in your code. Run az bicep build to compile the bicep file and check for syntax errors. If it succeeds without issues, your code is structurally sound. Then simulate the deployment with az deployment sub what if, location East US. This previews changes without applying them, showing what resources would be created or modified, like the 7 policies in our case. Seeing a clean what if output means your setup is ready for real deployment, no surprises ahead. Commit and push, git add dot, git commit -m policy setup, git push. This shows IAC in action. Bicep defines policies for compliance. If build fails, check for syntax errors using VS Code's linting, or validate with az deployment sub what if. Now, before we set up the pipeline in DevOps, let's create the YAML file in VS Code named fdoapolicy.yml. This file defines our CI/CD pipeline for automating the deployment of policies. It's the heart of our automation, turning manual steps into seamless workflows, which is incredibly empowering. Let's go through its structure and purpose. The file starts with the trigger section, trigger-main, which means the pipeline will automatically run whenever there's a push to the main branch. Perfect for continuous integration. Next, the pool section. Pool name default. This specifies the agent pool to use for running the pipeline, here using the default self-hosted or Microsoft-hosted agent. Then, the steps section defines the tasks. We have one task using Azure CLI at 2, which integrates Azure CLI commands into the pipeline. The inputs include Azure subscription, new connection FDOA to connect to your Azure subscription via a service connection. Add SPN to environment. True2 securely handles service principal credentials. Script type PS for PowerShell scripting. Script location. Inline script to run the script directly in the YAML, and the inline script itself. Let's create the pipeline. New pipeline using existing YAML file fdoapolicy.yml. Add service connection fdoa service connection for Azure Access. Run manually first. Watching the pipeline succeed is such a rewarding moment. Your automation is live. Now in Azure Portal, policy assignments, see new policies. All defined policies are applied successfully. Now is time to demonstrate incremental deployment with DevOps. Let's edit main.bicep in VS Code by adding a new module for testing. This addition allows us to see how changes are applied without recreating everything. It's a great way to showcase the flexibility and efficiency of infrastructure as code in action. The new module calls policy assignment rg.bicep with these details. The name is set to test policy module for identification. The scope targets the resource group rg test. to apply it specifically to RG test. In params, policy name is test policy for the assignment name. Display name is test policy allowed locations NIST SC7 to describe it clearly. Linking to NIST control for boundary protection. Policy definition ID references a built-in Azure policy for allowed locations. Enforcement mode use a modular mode variable for flexibility, for example, default or do not enforce. Save the changes, commit them with git commit -m and push to the main branch. Since our pipeline trigger on main, it automatically runs. Watch the logs in DevOps to see it deploy incrementally, adding just the new policy without affecting existing ones. Once successful, head back to the Azure portal, go to Policy Assignments, and you'll see the new test policy added successfully. This highlights how easy it is to iterate and scale your governance. Super satisfying to see updates roll out seamlessly. Additionally, in Microsoft Defender for Cloud, navigate to the Regulatory Compliance section to see how our deployed policies align with standards like FedRAMP and NIST. Here, you'll notice the compliance dashboard, updating with scores and recommendation based on the policies we've implemented, providing a centralized view of your security posture. This integration enhances continuous monitoring and helps identify gaps effortlessly, making it a powerful tool for maintaining federal-grade compliance. Let's open the Purview portal. With the free license, I cannot show you a lot of, but navigate to the Compliance Manager or Overview section to view the compliance score. Here, you can see how our deployed policies are successfully reflected, updating the score and tracking compliance. This demonstrates the AI agent's role in monitoring and reporting. Purview's AI provides insights and reports, aligning with continuous monitoring. It's like having a smart assistant overseeing your compliance. Game-changing.
In this video, we implemented policies as a code for FedRAMP compliance from preparation to deployment and monitoring. This is the scalable for production environment. Remember, always test in a dev environment first to avoid disruptions, and customize Bicep params for your scenario. This was a short video to help you better understand the policies as a code and how to use it. Thanks for watching. Leave a comment if you have questions. See you in next video.